Let's look at the problem together. Let f be a function defined on the set of positive rational numbers with the property that f of a times b equals f of a plus f of b. For all positive rational numbers a and b. Furthermore, suppose that f also has the property that f of p equals p for every prime number p. For which of the following numbers x is f of x less than 0? As we can all see that this is a general functional equation problem with the condition of this: f of a times b equals f of a plus f of b. And remember, the definition domain of this function is positive rational numbers. Positive rational numbers. Therefore, the a and b shall belong to this positive rational numbers. Good. And then we have a second relationship. That is f of p equals p for any prime number p. So now we want to consider what kind of f makes the value of f of x less than 0. So we shall start from the choices. Let's look at these choices. So all of them are fractions. Therefore, we should start considering the fractions. Or let's consider the numbers between 0 and 1, or maybe around 1. For example, d. So with such perception, we can start with some simple trials, especially for this equation. Let a and b take some special values or some special rational values, right? Then the most special rational value around 0 and 1, or in that neighborhood, shall be 1, right? We can't try 0. That's not in our definition domain. Therefore, let's first try a equals b equals 1. This is a very special case. So in that scenario, we have f of a times b, that is 1, equals f of a, that is f of 1, plus another f of 1, right? Then this simply implies f of 1 equals 0. Very interesting. As we said, we should try something special, and at the same time, we want to utilize this condition. F of p equals p. Then let's try this. Let's still make a times b equals 1, since we know f of 1 equals 0, right? But we make a equals p, and b equals 1 over p. Then we have f of 1, which is p times 1 over p, equals f of p plus f of 1 over p, equals p plus f of 1 over p, right? Don't forget this is 0. Therefore, we have f of 1 over p equals minus p. This is a very good result, because finally we found some values that make the values of the function negative. However, by checking these choices, we realize that first, none of these choices has a numerator of 1. Second, many of the numerators or denominators are composite numbers. Therefore, we should really try something new. So let's derive some new properties of this function. First of all, let's try make this numerator different from this denominator, right? Let's make a equals q, and b equals 1 over p. And in here, both p and q's are random primes. Primes p not equal to q, right? So this gives f of q over p equals f of q plus f of 1 over p. And from the above result, that equals q minus p. Therefore, as long as the prime number on the numerator is smaller than the prime number on the denominator, we get a negative value. But as we said, this is not enough yet. So let's also try something else. Let's make this a also a fraction. Let's say, what if that is 1 over q, and b equals 1 over p. Therefore, we have f of 1 over p times q equals f of 1 over p plus f of 1 over q, which equals negative p minus q. Good. With such results, this one and this one, these properties are sufficient to get the correct answer. So now let's try A, B, C, D, E one by one. So first, A. For A, we have f of 17 over 32. That certainly equals f of 17 plus f of 1 over 32. And since this is a composite number, 32, we want to rewrite it as a product of primes, or in other words, prime factorization, right? So that equals, so basically f of 17, that is 17, since 17 is a prime, plus f of 1 over 2 to 5. And this equals 17 plus 5 times f of 1 over 2, right? So that equals 17 minus 5 times 2. So these equalities are from these properties, right? So this equals 17 minus 10. That's 7, greater than 0, right? So A is not our choice. Let's look at B. F of 11 over 16, which equals f of 11 plus f of 1 over 2 to the 4th, which equals f of just equals 11 minus 4 times 2, which equals 11 minus 8, that's 3, still greater than 0. So B is not our choice. As we perform such calculation, we shall realize that we don't have to justify all the ABCDs. You should be able to find the patterns already, right? For example, this 9 is 3 square. So the value of 7 over 3 square basically equals 7 minus 2 times 3. That's 7 minus 6. Therefore, C is out. And the same thing for D. D basically equals f of 7 minus f of 2 minus f of 3, because 6 can be factorized as 2 times 3. Therefore, this equals 7 minus 2 and minus 3. That's 2, still greater than 0. Therefore, we should be able to conclude that E is our choice. But let's still justify that. So for E, f of 25 over 11, that is f of 25 plus f of 1 over 11. And that equals f of 5 squared plus f of 1 over 11, right? So f of 5 squared, that's 2 times f of 5, which is 2 times 5. And the f of 1 over 11, that's from this property, right? So that is minus 11. This equals negative 1, which is less than 0. Therefore, this confirms that E is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.